Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude. This is lecture number 5 on averages. So in this lecture, we are going to solve problems based on averages. So let us start with the first question. So first question is, three numbers are such that if the average of any two of them is added to the third number, the sum obtained are 168, 174 and 180 respectively. So what is the average of original three numbers? So let us have a look over the solution. So the important concept that will be useful in this question is average equal to sum upon number of terms. So according to question, it is given that a plus b upon 2 plus c is equal to 168. So if I take 2 times both the side, I will have a plus b plus 2c equal to 168 into 2. Similarly, b plus c upon 2 plus a is 174. This is given to us in the question. So it will be b plus c plus 2a equal to 174 into 2. So again, it is also given to us that c plus a upon 2 plus b equal to 180, which will be equal to c plus a plus 2b equal to 180 into 2. Now I have these three equations, okay, and I am interested in finding the average of a plus a, b, c. Okay, so to find the average of a, b, c, I need to know the sum of a, b, c first. So one way here is to solve this equations. Like I have three variables and three equations, and I can solve them to obtain the values of unknown. But the smarter way, the better way would be to add all the three equations. So on doing that, I will have 4 times of a plus b plus c equal to twice of 168 plus 174 plus 180. And on simplifying this thing, I will have a plus b plus c equal to 168 plus 174 plus 180 upon 2. So the average is equal to a plus b plus c upon 3 is equal to 168 plus 174 plus 180, because now we have already computed the value of the sum a plus b plus c, so we can easily substitute in this position. So the average will be 87. So the correct answer here is 87, that is option number A. So moving on to problem number 2. The average of 13 numbers is 80. The average of first 5 number is 74.5 and that of next 5 numbers is 82.5. The 11th number is 6 more than the 12th number and the 12th number is 6 less than the 13th number. What is the average of 11th and 13th number? So here, average of all 13 numbers is given to be 80. And the average of first 5 is given to be 74.5. And the average of next 5 is given to be 82.5. So let us see the deviation first. So deviation of this one from the 80 is minus 5.5. So 5.5 times 5 is minus 27.5. So the deviation of 82.5 from 80 is plus 2.5. So plus 2.5 times 5 will be 12.5. So the total deviation is minus 15. So now moving ahead to the another information that is given to us is 11th number is 6, or we can say 12th number is 6 less than 11. So if I suppose 11th number to be x, then the 12th number will be x minus 6 and the 13th number will be x. So the sum of these three numbers, 11th number, 12th number and 13th number, is going to be 80 times of 3 plus 15, and I can write it as 3x minus 6 equal to 255, which on simplifying I will have x equal to 87. So I am interested in average of 11th and 13th number. Since the 11th and 13th number are nothing but x and x, so the average will be x plus x upon 2, which is equal to x. So the x is already computed. So the answer is 87. So the correct option here will be option number B, that is 87. Let us move ahead to question number 3. The average of the marks of 30 boys is 88. So there are 30 boys and their average marks is given to us, which is 88. And when the top two scores were excluded, the average marks reduced to 87.5. So next here information given to us is, if the top two scorers are removed, their scores are removed from the sum, then the average reduces and it is 87.5. If the top two scorers differ by 2, then what is the highest marks? So let us have a look over the solution. So it is given to us that average of 30 boys is 88 marks and the average of 28 boys after excluding the first two scorers, highest scorers, so it is 87.5. So the difference of the number of students is -2 and the deduction in the average is minus 0.5. So the sum of top two scorers will be 30 times of minus 0.5 plus 87.5 times of minus 2. So it is minus 190. So now you have A plus B. Let us suppose A is the first highest scorer and the B is second highest scorer. So here we have computed A plus B equal to 190 and the difference between the top two scorers is 2. That is already given to us in the question. So you also know now that A minus B equal to 2. Since A plus B equal to 190 and A minus B equal to 2, both of these values are known to you. You can simply solve these two equations to obtain the highest marks, that is 96 marks. So the correct option here will be option number C, 96 marks. Let us move ahead to question number 4. The batting average for 40 innings of a cricket player is 50 runs. So a cricket player, you can suppose any of your favorite cricket player, and for 40 innings, his batting average is 50 runs. His highest score exceeds his lowest score by 172 runs. If these two innings are excluded, the average of the remaining 38 innings is 48 runs. The highest score of the player is. So this question is very much similar to the question that we studied in the previous slide, but the difference is the previous question was the setting of that question was in the student context and this is about cricket. The story in this question is about cricket, but the basic concept is going to remain the same. So let us look at the solution. So the average in 40th inning is 20 and the average in the 30th inning is 48. So the difference between these two, deviation in these two innings is -2 and the difference in number of innings is also -2. So the highest innings plus the lowest innings is equal to 40 times -2 plus 48 times -2, that is equal to minus 176. So highest inning minus lowest inning is 172. That is already given to us in the questions. Again, like previous one, you have two equations, two unknowns. Just solve them and you can easily obtain the highest score. Okay. So the highest score is 174. That is option number C. Moving on to problem number 5. A batsman scored 92 runs in his 15th inning. So a batsman have been playing a lot, and in his 15th inning, he scored 92 runs, which is a very good score. So, which increases his batting average by 4. So, his new batting average after the 15th match is increased by 4. So, what will be his batting average after 15th inning? So, what is his batting average? So, let us suppose. So let me first of all tell you the concept that will be very useful in this question. That will be sum equal to average into number of innings. So let us see the solution now. So till 14th inning, let us suppose his batting average was X. Okay. And since in the question it is given that after 15th inning, his batting average increased by 4. So the new batting average will be x plus 4. So now if I'm able to compute the value of x, then I can easily find what is the new batting average after 15th inning. So here, if the batting average till 14th inning is x, so using this formula, so I can put average equal to x and number of innings will be 14. So the sum, the total runs scored by him will be 14x, correct? And in 15th inning, he scored 92 runs. So I add 92 here. So this is nothing but the total number of runs he scored till 15th inning. I mean, I'm including the 15th inning runs as well. So this represents the runs scored by him till 15th inning. And also, it is given that in 15th inning, after 15th inning, his batting average is x plus 4. So again, using this formula, x plus 4 is the average and number of inning will be 15. So to know the sum, it will be 15 times of x plus 4. So that means these two things can be written with equal to each other, correct? Because both of them represents some total number of runs he scored till 15th innings, including 15th innings. Okay. So now both side you have x. Okay. You can easily solve them and you will have x equal to 32. So after 15th inning, his new batting average will be 32 plus 4, that is 36. So the correct option here is A, that is 36. Let us move ahead to question number 6. A cricket batsman had a certain average of runs in his 91 innings. Okay, so we have not given the exact average here, but there is some certain average. But we know how many innings, that is 91 innings. So in 92nd inning, he made a score of 54 runs, and thereby his average runs was decreased by 0.75. His average of runs after 92 inning is, so there is a batsman, okay, and his batting average till 91 inning is some x we don't know about, and in 92th inning he scores 54 runs. Okay, and after scoring 54 runs, his batting average dropped by 0.75. So we are interested in finding the batting average after 92th inning. So let us see the solution. So let us suppose the average in 91st inning be x, and it is also given to us that after 92th match, his batting average dropped by 0.75. So his new batting average will be x minus 0.75. So according to question, so again we are using the same formula, that sum equal to average into number of innings. That's exactly what we are here doing. So this is the x is the average. So the total number of runs scored by the batsman till 91 will be x times 91. That's exactly what is written here. Okay. And in 92th inning, he scored 54 runs. So we added it 54 runs. So this sum represents his total score after 92th inning. Correct? So now we have x minus 0.75. That is his batting average after 92th inning. Okay. And if I multiply that by 92, then I will have the sum, that total runs scored by him till 92th inning. So this sum represents his total score, total runs scored by him after 92th inning. So these two things on the left hand side and the right hand side represents the total runs scored by him after 92th inning. So these two things can be given equally. Okay, so now I can solve it. So it will be 91x plus 54 equal to 92x minus 92 times 3 by 4. That will be 123. So x turns out to be 123. So the average of run after 92th inning is 123 minus 0.75. So that is 122.25. So the correct option here will be 122.25. So that will be option number. Okay, so it should be option number A. Here it should be 122.25. Okay, so option number A is correct. So moving ahead to question number 7. A cricketer had a certain average of runs for his 64 innings. Again, this in this question also we are not provided with the average, exact average, but we know certain average is there. And in his 65th inning, he bowled out for no scores in his part. That means in his 65th inning, he scored 0 runs. Okay, so this brings down his average by 2 runs. So his average dropped by 2. And what is his new average? So that is what we are interested in. So let us suppose the average in 64th inning is x. And since his average after 65th match dropped by 2, so the average, new average is going to be x minus 2. Okay. So according to question, 64x plus 0 is equal to 65 times x minus 2. So I think I don't have to again explain how we got to this equation. 64x represents the total number of runs he scored till 64th inning. And 0 is the new score in 65. So 64x plus 0, because there is no new score added. So 64x plus 0 is his runs scored after 65th inning. And 65 times x minus 2 is total runs after 65th inning. On solving this, you will have x equal to 130, and the new average of runs will be 130 minus 2, that is 128. The correct option here will be 128. Moving ahead to question number 8. A batsman scores a certain runs in 72 innings. In next 2 innings, he scores 54 and 36 respectively. Therefore, decreases his average by 3 runs. So find the average after 74th inning. So again, we have a batsman who runs have certain average till 72th inning, and in the next 2 inning, in the 73 and 74, he scored 54 and 36 runs respectively. And after this score, his average dropped by 3 runs. So what will be the average, the new average after 74th inning? So we are going to use the same concept that we used in the previous question. So you can see that the all the questions that we are doing are mostly based on the same concept. So the same concept, that is sum equal to average times of number of innings. So let the average in 72th inning be x, and it is already given in the question that his average dropped by 3. So it will be average in the 74th inning will be x minus 4. Sorry, x minus 3. So according to question, 72x plus 54 plus 36. So 72x represents his score, total runs scored by him till 72th inning, is 72x. Okay, and we are adding 54 and 36. That makes this total as his runs scored by him till 74th inning. And this thing is also the same thing which represents runs scored by him till 74th inning. So on solving this, we will have x equal to 156. So average of runs after 74th inning is 156 minus 3, that is 153. So the correct option here will be option number C, 153. So moving on to problem number 9. A batsman scores 556 runs in 26th, 27th, and 28th and 29th innings together. And now his average increases by 4 runs. So there is a wonderful batsman who scores 556 runs in these 4 consecutive matches. Total runs is scored by him. So find the average run after 29th match. So we are interested in finding the average of his average after 29th match. So let average after 25th inning be x. So the average after 29th inning is going to be x plus 4 because it is given in the question that his average increased by 4 after 29th innings. So according to question, it will be 25x plus 556 because 25x is the total runs scored by him after up to 25th match, and 556 is his new total score up to 29th. So in the 4 innings that we are talking about, 26, 27, 28, 29. So this whole thing on the left hand side represents his total scores till 29th inning. And on the right side also 29 into x plus 4 represents his score till 29th inning. So on solving this, you will have x equal to 110. So average of run after 29th inning will be 114. So that means the correct option here is option number D, that is 114. Moving on to problem number 10. The average weight of A, B, and C is 65. If the average weight of C and B is 61.5 and the average weight of A and C is 68.5, then what is the weight of C? So average is about A, B, C, CB, and AC is given to us, and we are interested in finding what is the what is the weight of C. So let us see which concept will be useful here. So the concept that will be useful here is, first of all, the average is given by sum upon number of terms. Okay. And secondly, the weight of C will be given by weight of BC plus weight of AC minus the weight of ABC. Okay. So the average of ABC is given to us, that is 65. Average of BC is given to us 61.5. Average of AC is given to us, that is 68.5. So C will be equal to average BC plus average AC minus average ABC. So that okay. So this is not the average here. It will be weight. This is also weight. So the weight will be 61.5 is the average. Twice it will give the sum of weight, combined weight of BC. So again 68.5 is average weight of AC. So making it twice give you the combined weight of AC. And again same with the 65 into 3. And on simplification you will have 65 kgs. So the correct option here will be option number D, that is 65 kgs. So let us move ahead to question number 11. The average weight of 3 men A, B, C is 84 kgs. Another man D joins the group and the average now becomes 80 kgs. If another man E, whose weight is 3 kg more than D, replaces A, then the average weight of BCDE becomes 79 kgs. Then the what is weight of A? So let us see the solution. So the average of ABC is given to be 84 kgs and the average of ABCD is given to be 80 kgs. If you now see, there is +1 change in number of people and -4 deviation in the average weight. So the weight of D will be given by 80 times of +1 plus 3 times of -4, that is 68 kgs. And also it is given to us that the weight of E is 3 kg more than the D. So therefore we write E equal to 68.3, that we write E equal to 68 plus 3, that is 71 kgs. So average of ABCD is 80 and BCD is 79, that is also given to us. So deviation is -1. So A minus E is going to be 1 times 4 equal to 4. So A minus 71 equal to 4. So A is 75 kg. So the correct option here will be A, C, that is 75 kgs. So moving on to the last problem, that is question number 12. The average of ABC is 18 and that of CDE is 12 and that of E and F is 6.5 and that of E and C is 3.5. What is the average of A, B, C, D, E and F? So the average of A, B, C is given to us, C, D, E and is given to us, E and F is given to us, E and C is given to us, and we are interested in combined average A, B, C, D, E, F. So the formula that will be useful here is sum equal to average into number of terms. So for getting D, we subtracted one equation from another. So A plus B plus C is 18 into 3. So 18 is the average and 3 times gives us the sum A plus B plus C. And that is 54 and name it as equation number 1. C plus D plus E equal to 12 times 3, that is 36 and it will be equation number 2. E plus F equal to 6.5 times 2, that is 13 and it will be equation number 3. And E plus C equal to 3.5 times 2 equal to 7 and it is equation number 4. And from equation 2 and 4, D equal to 29 and the average A plus B plus C plus D is the sum is going to be 54 plus 29 plus 13 and upon 6 give you 16. So that is the average of A, B, C, D, E, F. So the correct answer will be 16, that is option number A. So that would be all for this lecture and I will see you in the next part of average in which we are going to study previous year questions. So thank you very much.